Alcohol is considered a very short chapter, yeah. I think I can get the first 30%, 20% done by today. Maybe. Alright guys, let's go. Okay, alcohol are organic compound that contains your hydroxy group. Which is OH group. General formula CnH2n plus 1 OH. Okay, so how you name alcohol is by adding an O. Okay, so the position of your hydroxyl is basically where you insert your OH. That's it. So guys, we have three different type of alcohol. We have a primary, in which your OH group is attached to a carbon to 1R. This one is gonna be carbon to 2Rs. This is a carbon to 3R, yeah. Okay, so you guys know how to differentiate your primary, secondary, and tertiary? Alright guys, now let's go. Kid, I'm gonna give you some alcohol. I want you guys to start drawing it. Please name primary, secondary, tertiary for me. Okay, guys, draw this out. For R group is just any carbon. R group is just any carbon. Alright, guys, let's go. Always repeat us this way. Okay, done. Alright guys, I'm gonna label everything here. This is a secondary, a tertiary, and a primary. What's that? You. Bye bye. Okay, then this is a primary, a secondary, and a tertiary. Know how to identify. This is also primary, secondary, primary, tertiary, and a tertiary. Okay? Know how to do. Need me to explain or not? Don't need, right? Know how to differentiate. So primary means your COH is connected to 1R. Tertiary, your COH is connected to 1R, 2R, 3R. Let's see. Secondary, you see 1R, 2R. Clear? Alright guys, for alcohol, they always have a relatively higher melting point or higher boiling point. Okay, than other organic compound due to a hydrogen bonding. You have OH group, right? So OH always have a hydrogen bonding between them. Okay, now go wash your hand, go. Alright then, nice. As the number of alkyl group increases, okay, so as the number of carbon chain increases, what you are getting is that you will have a solubility of your alkyl, sorry, solubility of alcohol in the water decreases. That's it. Okay, please write it down. We are moving on. Hydrogen bonding is a weak one. Since when, oh, 哥哥? Hydrogen bonding is the strongest IMF 呀 strongest IMF 啦，小朋友。Since when got weak one, boy? Okay Okay, guys, next page, please. When the sun goes down, always remember us this way. All good. All right, guys, now let's look at the question. So, kid, what we have here, okay, compare boiling point of alkane, halogenoalkane, and also alcohol. Okay, guys, give a ascending order of boiling point and provide explanation. So, guys, what I want you guys to do is all the 3 carbon, let's compare 3 carbon here. I'm going to draw an alkane. An alkene, an alcohol, so a halogenoalkane, and alcohol. Okay, please draw this out. Okay. The next thing is, guys, whenever they ask you to compare boiling point, remember this boiling point, please compare IMF. Okay, so when you see the word boiling point, please compare IMF, okay? Sun goes down. Okay, guys, first, okay, let's look at alkane. Alkane is non-polar. What is the IMF present? Alkane is only ID. ID, right? Okay, alkene is also non-polar, is also ID, correct? Okay, guys, what about alcohol? You have ID, you have PDD, Epstein file. Epstein file. How the hell you know Epstein file? You have PDD, you also, that's it, right? Yeah, my kid tell me IPDD, the Epstein file. Yeah, that's a halogenoalkane, correct. And finally, alcohol, we have ID, PDD. Okay, and also we have a hydrogen bonding. Yeah. So hydrogen bonding is the strongest, right? So which means the highest melting point is always alcohol. Followed by a PDD, which is a haloalkane. Followed by what? Okay, guys, both alkane and alkene has ID, but okay, ID increases when the number of electrons increases. This is a C3H8. This is a C3H6. So you see that you have a bigger molecule here. So which means stronger idea. Then we have alkane. At last, we have alkene. That's it. Okay. Yeah, exactly. Then you give it to me. Give it to your Valentine date. V-best angpao. Alright, guys. Next, we have acidity of alcohol. Alright, guys, this is quite important. I mean, like, not really important now, just quite. So again, let's look at your alcohol again, guys. Okay, we're gonna draw an alkane. No, sorry, we're gonna draw an alcohol. Hey. Draw it up. Alright, guys, now let's look at your acidity of alcohol. So you see, for alcohol, right, first thing is you always have this alkyl group. Look at alkyl group, right? What do you call this as? This is a 1, 2, 3, 4. It's a C4H9. And this is an alkyl group, right? So guys, remember what is the property of an alkyl group? Remember this. Okay, alkyl group has what property? Has an electron donating property. Am I right? So what it does? Pushes electrons towards OH bonding, right? So which means, guys, you see, what they're gonna do, they'll push the electron towards OH. Okay, so right now your OH has a lot of electrons. Then your OH bonding is gonna be stronger. So it's gonna strengthen up your OH. So which means, right, your OH is harder to break now. Okay, so which means it's harder to form a H plus, which means it's less acidic. Done. Alright, guys, I can say that alcohol are never acidic. I remember. On one reason, you have electron donating alkyl group carrying a positive inductive effect. Correct. So it pushes the electrons towards OH bonding and strengthening it. Okay, so cannot be broken, H plus cannot be ionized. That's it. So it doesn't form a H plus, yeah. That's it. Done. Alright guys, next. Alright kid, what we have here is a combustion of alcohol. So guys, when you combust alcohol, you are getting, just like any other combustion reaction, we will have a CO2 and a H2O, that's it. So it's always a CO2 and H2O when you combust an alcohol. Alright guys, now, let's say if I have this. Okay, please balance the equation. Alright guys, I'll be getting a 5 CO2, 6 H2O, correct or not? 6 plus 10, 16, correct. 16 minus 1, 15. 15 over 2. Done. Can I? Alright guys, next we have substitution to form a halogenoalkane. Oh my god, this is so important. Alright guys, we can always substitute with a hydrogen halide, okay, such as a HCl, okay. So in the alcohol is substituted, yeah. Alright guys, now let's say if I have a C2H5OH plus a HCl, guys, substitute it for me, you'll be getting a halogenoalkane. Alright guys, so the Cl will be substituted, yeah, into your alcohol. You are getting a C2H5 Cl. Okay, then plus a H2O. That's it. Okay, please write it down, yeah. Alright guys, the second reaction we have, right, it's with a sulfur dichloride, yeah, which is a SOCl2. This is the most important one, yeah. Alright guys, I can substitute a halogenoalkane SOCl2 into, halogen Cl into an alcohol with SOCl2 under room temperature. Okay, let's say if I take the same thing plus SOCl2. So what it's going to turn into, right? I'll give you the equation. You get a C2H5, this time with a Cl. Then plus a SO2 plus a HCl. That's it. And when a HCl is formed, you will see a steamy white fume. That's it. Okay? Alright guys, I want you guys to balance another equation for me, which is this one. Okay, this time I want CH2OH2. Alright guys, please balance this equation for me. Oh yeah. Done? Alright guys, you see right? For this reaction, 2OH will be substituted, yeah? So 2OH will be substituted to turn into a CH3Cl2. And you need 2SOCl2. 2SO2 is formed. 2HCl is formed. That's it. You just have to balance the equation by adding everything by a 2. That's it. Okay. With that said, kiddos, I will stop the lesson here.